Topic: light and sound. Why do we see lightning before thunder? Don't go out tonight. A huge storm is coming. Look at the weather outside. See, there's a huge lightning strike. Now, very soon, you're going to hear some thunder. I told you. Don't get scared. It's just thunder. Do you know why you saw the lightning before you heard the thunder? I will tell you. An interesting fact is that lightning and thunder occur at the exact same time. Then why do we see lightning first? This is because light travels faster than sound. The speed of light is 300 million meters per second, while the speed of sound is only 340 meters per second. Thus, the light from the lightning travels much faster to our eyes. As a result, we first see the lightning, shortly followed by the sound of thunder.
All right, go ahead and give me a smiley, medium, or sad face if that's making sense. Again, they said that light travels a lot faster than sound, so that's why we see the light first. Even though they are both created at the same time, one of them is seen first. Light is seen first because it's faster. Go ahead and give me smileys, medium, sad face. Jalen, Kamal. Jaime, Noah, Mallory, thank you. Anissa, Seraphim, awesome everybody. All right, let's go ahead and break this down even further. I'm going to go ahead and stop that, jump back to our PowerPoints, and let's take a look here.
Right, so learning a bit about the speed of light. So light travels faster than anything. In fact, light is the fastest is the fastest known wave that we know of, right? So light, as it said in the video, approximately travels at 300 million meters per second, where the sound in air, right, because sound can travel faster through different mediums, it travels at around 343 meters per second, right? That's what I was trying to say before. We currently know of nothing else that can travel faster than light. So the speed of light is actually the same for all electromagnetic waves, right? So all the different wavelengths that we learned about yesterday, like ultraviolet, infrared, the visible spectrum, X-rays, they all actually travel the same speed, right? So radio travels longer distance, but over a longer period of time. Gamma rays travel shorter distances, all right, but over a shorter period of time. So all the waves, they actually even out to the same speed, all right? And that's the reason for these differences up here is because of those wavelengths, right? We learned yesterday that the shorter the wavelength, right, the more waves you have in a smaller space, right, the faster the frequency is. That's an interesting application right there. So for number 2, we're going to mark the word same in our notes for number 2. Go ahead and raise your hands when you're ready to move on. It's just a one-word answer.
Okay, so this idea of all of the waves being the same speed, even though they're traveling different distances and times, can be a little bit confusing. So let's go ahead and use an example that's a little bit simpler here. So let's imagine we have a car that travels a long distance, 100 meters, in 100 seconds, which is a long time. So taking a look here, what should I plug in for my distance? Go ahead and tell me in the chat. All right, so distance is going to be my first box here. What should I plug in here? What number goes here? Go ahead and tell me in the chat. Awesome, I see Angelina. Yeah, give me units. I love that. Let's get some more answers. Thank you, Cody, Callie, Jayland, Kamal, Jonathan, Jaime, Shayna, Noah. Thank you, Mallory, Carlos. Thank you, Matthew. Yeah, so taking a look here, meters we mentioned is our distance, and so that should go in the first box here. So 100 meters right here. And what should I plug in for my time? Include those units, tell me in the chat, because it's always good to practice understanding units. What should go in for my time? That's our second box here. Yeah, 100 seconds, excellent. So taking a look at this, 100 meters divided by 100 seconds equals what? What is 100 divided by 100? Everybody in the chat, this is an easy calculation. Anything divided by itself equals what? Well, that would be if you are subtracting, Mallory. So again, division's a little bit different. There you go. Awesome correction. Thank you, Cody, Noah, Jalen. Yeah, anything divided by itself just equals 1. So 100 divided by 100 equals 1. And our units here would be meters per second. Okay, so a long distance over a long time, my speed ends up being 1 meter per second. Now let's go ahead and try a short distance over a short time. So this time, what do I plug in for my distance here? Give me a number, give me units. If I have a short distance of 4 meters in 4 seconds, a short time, what do I plug in for distance here? Excellent. Let's get some more answers as well. Kai, Chantel, Kai, Chantel, Joseph H, Kalina, Benjamin, Anissa in the chat, Carlos. Thank you, Seraphim. Yeah, so our distance here is 4 meters divided by our time, which is what? Again, the actual question tells you, so what's our time? A number, give me units. Excellent, yeah, it's just going to be our 4 seconds right here. So same thing here, if we have a short distance over a short time, tell me in the chat, 4 divided by 4 equals what? 4 divided by 4 equals what? Yeah, 4 divided by 4 equals 1 still. Thank you for including units, meters per second. So taking a look here, if I travel a long distance over a long time or a short distance over a short time, my speeds end up being what? Tell me in the chat. My speeds here end up being what? Are they the same or different? Excellent. I see Angelina. I see Noah. Yeah, exactly. They end up being the same. All right. This should make a lot of sense, right? Let's imagine that you're walking, right? If you have to walk a long distance, it's going to take you a long time. And even if you're walking at the same speed, if you walk a short distance, it'll take a short time, right? So again, you can be walking at the same speed and have different distances in time, as long as those distances in time are proportional to each other. So that's the exact same way that electromagnetic waves can all have the same speed, even though they all have different wavelengths. Okay, smiley faces, emojis in the chat if that makes a little bit more sense. I know conceptually it's a little bit hard to understand, so I wanted to do a calculation, and hopefully that helps. Excellent. All right, everyone. Let's go ahead and take a look here at how to actually use the speed of light equation. So here's the deal. Light is the fastest traveling thing in our universe. All right, it travels very fast at 299,792,458 meters per second. Say that 10 times fast. That's a big number. However, even though it is the fastest thing to travel in our universe, it still takes some time to travel. So let's take a look at a problem here. So the sun is 149,597,870,700 meters away from Earth. Okay, so the question is, how long does it take sunlight to reach the Earth? So we have an equation for speed, where speed equals distance divided by time, and this can be rearranged. So if we just take a look here, if you just switch speed and time, you now have an equation where time equals distance divided by speed. Go ahead and give me a green check, orange X if you're okay with that. Again, you can just rearrange that equation. That's just an algebra thing. All right, so let's use this new equation. So my distance here, all right, we need to annotate here. So let's actually annotate our two numbers first before we even take a look at our equation. So 299,792,458 meters per second, is that my distance or my speed? Tell me in the chat. Is this a distance or a speed if we're talking about meters per second? Kind of like miles per hour in a car. Meters per second, like miles per hour. Yeah, good correction, Cody. No worries. Yeah, this is actually our speed. So I'm going to label this as V for velocity or speed. And then tell me in the chat what would be 149,597,870,700 meters. Meters now is what? Think about a 100-meter race. What's that telling you about the race? Yeah, it's telling you the distance of the race. So this should be my distance. All right, so let's go ahead and plug those numbers in. So first I need to plug in my distance, this big 149 billion number, meters, all right, divided by my speed or velocity. So 299,792,458 meters per second. All right, those are some big numbers. All right, I'm going to go ahead and give you 45 seconds because I know those are some big numbers. Plug those into a calculator and go ahead and tell me what do you get. All right, awesome. I see lots of good answers here. So yes, you should be getting 499. I'm just going to round because there's a bunch of zeros after that. So just 499 seconds. All right, so it takes the sun, the light from the sun, to travel. Okay. It takes the light from the sun 499 seconds in order to get to Earth. All right, so again, it takes light some time to travel. All right, this is the answer to number 3. Go ahead and in the first box, put the number 499. And in the second box, the unit is just S. Don't type out seconds, it should just be S. Go ahead and raise your hands for number 3. You have 30 seconds. Go, go, go. All right, so we want to figure out what is 499 seconds in minutes. So again, we know how long it takes for the sunlight to reach the Earth in seconds. Now we're going to go ahead and figure out how long does it take in minutes. Now, you might be able to do this intuitively just because you know how many seconds are in a minute, but we're going to go ahead and practice this using conversion ratios just because this is a good skill for us to have, is to be able to actually mathematically convert more complicated numbers. So what we know right now is that 1 minute is the same as 60 seconds. So what we can do is we can put that into fraction form. And the reason we can put it into fraction form is because conversion ratios always actually equal 1. For example, if you take 1 minute divided by 1 minute, that equals 1. That's that makes a lot of sense. Go ahead and give me smileys or emojis in the chat if that makes sense. Right? 1 minute divided by 1 minute absolutely equals 1. Anything divided by itself equals 1. Cool. Now, as mentioned though, we said that 1 minute is actually the same thing as 60 seconds. Okay, so normally 1 divided by 60 doesn't equal 1, but 1 minute divided by 60 seconds, those things are actually identical to each other. So when we include units, that means that these are identical to each other. So it's still being divided by itself, which means it still equals 1. Okay, same thing over here. I could do 60 seconds divided by 60 seconds. Obviously, that equals 1. But as we mentioned, 60 seconds is the same thing as 1 minute. Okay, so 60 divided by 1 normally doesn't equal 1, but 60 seconds divided by 1 minute does, because those are identical to each other. Go ahead, give me a green check, orange X if that's beginning to make sense. Again, units matter when we do division. Units matter when we do division, okay? So since these things all equal 1, all right, so since all of these different fractions actually do equal 1, I can throw them into equations and I can use them to convert units without changing the actual identity of this time. So let's go ahead and try it out, okay? Because it's always easier to practice. So we want to start with what we know. So the question is, what is 499 seconds, the time for sunlight to reach Earth, in minutes? We need to start with something that we know. So I need to start with a number and units. Take a look at our question. What number do you see? And give me its units. What number do you see? And give me its units. Thank you, Angelina. What is our number and what is its units in the question? Thank you, Cody. Excellent, Chantal. Excellent, Matthew. Yeah, absolutely. So the number I see here is 499 and its units are seconds. So that's what we're going to start with right here. 499 seconds. Okay. Now, when I do conversions, it's a lot easier if everything's in fraction form. So in order to turn 499 into a fraction, I just need to put it over what number. Dividing this by what number will not change it. Anything divided by what will still be itself. Anything divided by what will still be itself. Go ahead and tell me. Awesome. I see Angelina. I see Joseph. Yeah, anything over 1 is still itself, just like how 3 over 1 is still 3. In the same way, 499 seconds over 1 is still 499 seconds, but now it's in fraction form. Okay, smiley faces, emojis if you feel comfortable with that. Smiley faces, emojis if you feel comfortable with that. Excellent. All right, so now we want to figure out how do we convert this. So I want to get rid of seconds here. In order to get rid of seconds in the next step, it needs to go on the opposite side of our fraction because that will divide or cancel it out. So if it's on top at the start, where does it need to go in the next step to be on the opposite side? The top or the bottom? Opposite side of a fraction. Thank you. I see Angelina coming in with participation. Thank you, Matthew. Let's get Callie, Kamal, Jaime, Shayna, Noah, Carlos. Not asking for raised hands, asking for participation in the chat, please. Yeah, so if it starts out on top here, in the next step, it needs to go on the bottom to divide it out or get rid of it. Now, what I'm solving for goes on top. So in the chat, what am I solving for? What units am I trying to get to? I'm starting at seconds, but I should be ending at what? What am I solving for? Yeah, exactly. We're solving for minutes here, right? So this right here is what I'm trying to get to. So that's what we put on top. We always put what we're solving for on top. So minutes goes on top. Now, whenever I convert things, again, conversion ratios have to come from something that's always true. And what's always true is that 1 minute and 60 seconds are identical to each other. So I need to use one of these fractions that we just talked about on the previous slide. Go ahead and point for me or tell me in the chat, left or right, which of these fractions has minutes on the top and seconds on the bottom. Either point for me on the board or tell me in the chat, left or right. Which one has minutes on the top and seconds on the bottom? I see purple on the board. Yeah, so the only one that makes sense here is to use this conversion ratio. Again, this conversion ratio I can plug in because it's still just 1, right? 1 minute divided by 60 seconds is itself. So 1 minute goes on top, 60 seconds goes on the bottom. Okay, so we've gotten rid of seconds, we're left with minutes. That's the units that we want. But now we just need to multiply this out. So when we multiply fractions, again, multiply across the tops. So I have 499 times 1 on the top. Tell me in the chat, what does that equal? Yeah, anything but times 1 is still itself, so I should have 499 on the top. And on the bottom, what is 1 times 60? Again, also really easy. Anything times 1 is still itself. Yes, exactly, Mallory, exactly, Angelina, this would be 60. Okay, grab your calculators and tell me now, top divided by the bottom, how many minutes are we left with? Okay. We started out talking about 499 seconds. Now it should be in minutes. How many minutes does this equal? 499 divided by 60. What do we get? Yeah, exactly. So solving this, you should be ending up with, I believe you do need to round that last number, so I believe it should actually be 8.32 minutes. Okay. Now again, this is something that you could probably intuitively do, right? If you have 120 seconds, you know that that is 2 minutes, right? Because 120 divided by 60 equals 2 minutes. So you could have just taken this number and just known, oh, I need to divide it by 60. But that's not always true of every conversion you have to do, so it's still helpful to understand how to do these steps in case you run into a conversion that's more difficult. Go ahead and give me a green check, orange X if that reasoning makes sense. So I know intuitively you probably could have gotten the answer very quickly, but it's helpful to know these steps in case we ever run into something more complex. Excellent. All right, so this is going to be our answer for number 4. Please raise your hands. First box is 8.32. Second box is minutes. 30 seconds to raise your hands.
So it takes light about 8 minutes to travel from the sun to the earth, which means that the sun is 8 minutes older than the light that you actually see. So if you want to think about it that way, the extreme distance that light has to travel through space, it's kind of like when you see into space, it's kind of like a rudimentary form of time travel because you're actually seeing into the past. That's not important. That's just a fun little tidbit right there. It also takes 8 minutes from the sun going out before we stop seeing the light. So a light year is the distance that light travels in 1 Earth year. So it's measuring distance, not time technically, all right? But sometimes we do use it as a unit of time, but it is a measure of distance. All right, so let's move on from there. Number 5 is going to be the word older. Astronomy is pretty cool if you want to study that. Number 5 is going to be the word older, so go ahead and mark that, and I will start a timer. Raise your hands when you're ready to move on.
Yeah, I don't know if you saw that in the chat, but one of the most amazing things is that there are actually many stars in our universe that we still see to this day, even though they actually died billions of years ago, just because it takes so long for light to travel along long distances. So even though light is the fastest traveling thing in our universe, it still takes some time to travel. All right, let's go ahead and take a look here. So a lightning bolt strikes 16,100 meters away, which is about 10 miles away. And we want to know how long would it take to see the lightning versus how long would it take to hear the thunder. So remember that we know the speed of light and we know the speed of sound. The speed of light is 299 billion blah 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 meters per second. The speed of sound is 343 meters per second. Much, much slower. So here's our equation again. Time equals distance divided by speed or velocity. We're going to go ahead and first calculate with light. Now, I do recommend using Google Calendar calculator. So if you go and you just Google the word calculator, a calculator will pop up for you because this way it won't put it into a funky form. It'll give you the actual answer. Otherwise, if you use a normal calculator, it might put it into scientific notation. So just as a helpful hint, when we do the calculation, go to Google Calculator. Okay, so taking a look here, we have time equaling distance divided by speed. So let's go ahead and take a look here. I have something that's 100 16,100 meters away. So that should be my distance. I'll plug that in, 16,100. Okay, and I need to divide it by the speed of light. So tell me in the chat, should I use this big number or the small number as my speed of light? Big number or the small number for my speed of light? Thank you, Angelina. I see Chantal. Which number should I use for my speed of light? So let's go. Tell me in the chat, please. The 299 billion number, the big number, or the small number, 343? Yeah, we said that the speed of light is actually this first number, so we'll plug in that one instead. All right, so we're going to go ahead and do 299, 792, 458 meters per second. Okay, so we have this right here. All right, so what we're going to go ahead and do is I'm going to go ahead and actually show this to you on Google Calculator, because again, I highly recommend you actually use Google Calculator. Let me share with this. So again, just go to Google the word calculator, big for us. All right, and so we said, oh, let me actually go back to the PowerPoint really quick. We said it was what? 16,100 divided by 299,792, 458. So let me go ahead and share that now, and go ahead and tell me in the chat, what do you get? I'll go ahead and give you 45 seconds to calculate that. It should be a super tiny number because again, it's going to be really, really fast. Go ahead and tell me what you're getting. Cody, make sure you do the 16,000 first. All right, it looks like you flipped them, so make sure the 16,100 goes first. Awesome, I see Mallory, I see Angelina in the chat. Excellent. Again, think about how light should be super fast, so it should be a short amount of time. Short amount of time. All right, start getting those answers in the chat, please. Thank you, Joseph. Waiting on some more answers. Callie, Jalen. Looking good. All right, make sure you're not just copying other people. We are going to actually have all of these numbers here. So you should end up with 0.00004 zeros, 537. Smiley faces emojis in the chat if you feel comfortable with that. Again, make sure you know how to use your own calculator. Looking good. All right, let's go ahead and plug that in here. So over here, we ended up with 0.0000537 seconds. So in the first box, that's your number. Please make sure you have all the zeros and all those numbers, 537, otherwise the computer will mark it as incorrect. Unit should be S for seconds. Only the letter S though, okay? You have 30 seconds to go ahead and fill that in and raise your hand. So now let's go ahead and just do this for sound. All right, so we have again, distance divided by speed here. It's still the same distance, right? It's still the 16,100 meters away. So that's going to go in my first box here. But this time, what should I put in for my velocity of sound or my speed of sound? What number goes in for my speed of sound? Remember, I had two different speeds here, so which one should I use this time? Thank you, Noah. Thank you, Angelina. Which one do I use this time? Yeah, absolutely. So we said the speed of sound is 343 meters per second. So that goes here. All right, this one you can use any calculator. Go ahead, grab your calculators and tell me in the chat, what do you get? This one should be a nice, quick calculation. It's a much smaller amount of numbers to plug in. Tell me, what are you getting? Yeah, go ahead and give me 2 decimal places, y'all. Awesome, everyone. Yeah, so you should be getting 69, oops, sorry, clicked the wrong thing. So you should be getting 46.9, and then that 3 is followed by a big number, by an 8. So do I leave it as a 3 or should I round up? It's 46.938, blah, blah, blah. So that big number after the 3, should I keep it a 3 or round up? Yeah, I actually do need to round up. So it should be 46.94. 46.94. All right, so that's our answer to number 7. Go ahead and fill in the first box with your number, second box with your unit, and then we're going to go ahead and analyze our results. We calculated the speed of light, we calculated how long it took the lightning to reach us versus the thunder. Now we just need to analyze it. So 1 slide left, work fast, 20 seconds to raise your hands for number 7.
That light has traveled 16,100 meters in 0.0000537 seconds. That's very fast. And sound traveled the same distance in 46.94 seconds. So that's much longer to hear the sound. Now, if you just want to compare those two values, the time it took light to travel that distance, you're not even going to notice the passage of time really. And then the amount of time of like 46 seconds, that's actually the amount of time we can measure. So that explains why you see the flash of lightning almost at like an instant, and then you can literally just count the seconds to where you can hear the thunder. All right, so pretty interesting. All right, so today we were able to understand the speed of light, and we did some calculations involving the speed of light. Also mentioned some interesting things about the speed of light in space and how that works. So if you'd like to go ahead and tell us how you feel about today's lesson. Not anything too difficult today, only just some unit calculations we did involving speed and time and distance. Nothing that we haven't done before, just implying it in a different way. All right, great job, everyone. So let's just go ahead and end it right there. So if you haven't already, go ahead and turn in your notes. If there's anyone that happened to miss anything toward the beginning, just let us know and we'll help you out. Everyone else, go ahead, have a great day, and we'll see you guys back here on Friday.